Warm greetings and very good afternoon, dear friends and students. Now we are going to see about the case of reinforced cement concrete structure. What are the sections available in the case of RCC structural elements, either in the case of beam or in the case of the slab elements? So you know that the case of RCC structures, the main function of the concrete is to take the compressive stress or the compressive strength. You know that the concrete is very weak in taking the tensile strength or the tensile stress. So that's why we are introducing the reinforcement. In the case of the torsional reinforcement, either tor steel, which is having Fe 4 and 5 or Fe 500. So nowadays, Fe 550 also came into the market, and which is having a more tensile strength and the torsional rigidity in the case of the beam or in the case of the slab. So here, in the case of the RCC structural element design, you have to follow the IS code, the IS 456. So that is very much important. So what are the various properties of the materials like cement, concrete, having the fine aggregate, coarse aggregate, and any additive added for good bonding. And also we're adding say some portion of the water resistant additive also. In addition to that, we're adding the reinforcement in the form of tar steel Fe 500 or Fe 4 and 5 or Fe 550, mainly to take care of the tensile strength. So the concrete is very weak in tension or taking the tensile strength. In addition to the bending stress. So what is the allowable bending stress for various type of mixtures like M20, M25, M30, M35, and even you can go for the rich cement mixed concrete for the flyover or any other offshore structures. In addition to that, nowadays we are going for up to M75 concrete, that based on the requirement. So in the case of the normal structures like the residential building and the commercial complex structure or the industrial building, we are going a minimum of M25 concrete. So M25 means the mixture of the concrete of 25 Newton per square millimeter of a compressive strength for the curing of 28 days. If you are testing the concrete block of size 150 mm by 150 mm by 150 mm, the compression should not less than is 25 Newton per square millimeter. So definitely you will get either 28 or 30 or 32 megapascal. So even nowadays we are going for the flyover like the various cities nowadays. You can see in Tamil Nadu the number of flyovers are going on. They are using the rich cement concrete like M35 or M40 concrete. Even nowadays they will go up to M30 concrete. So that depends upon the type of structure and where it will be used. In the case of the offshore structures, the rich cement concrete should be used. Even they can go up to M60 to M75 mixture of concrete. So we have to analyze the various properties of a materials like cement, coarse aggregate, fine aggregate, and also the water and additive mixtures. So in olden days they have used the ordinary Portland cement, but nowadays we are going for to reduce the emission of carbon dioxide and the particulate matters PM. We are using the pozzolana cement, PPC, Portland pozzolana cement. Even they have replaced more than 25 percentage to 50 percentage of the Portland cement. So these are the advantage of the RCC concrete. So mostly in in the international world, we are using the RCC only. Nowadays only even the composite material has come to replace some portion of the concrete. So it has been existed more than 75 years in the market. Slowly, even the polymer concrete is also coming into picture, but it's not so much in the case of the various structures like the industrial building or the residential building or the commercial complexes. So it is in the research side, only very few structures are coming up. The case of the polymer that is completely replacing the cement, that is the emission of carbon dioxide to go for the sustainable environment and for reduction of the CO2 and the particulate matters. So the main point here is even nowadays they are using the fibers of very small fiber of 0.5 mm or 1 mm or 1.5 mm, either glass fiber or any other fibers of the composite materials, right, to go for the alternate materials for the steel also. So a lot of research are going on. Even nowadays, you can see the pre-engineers building is coming up, and also the prefabricated buildings are also coming up for the past 4 to 5 years in India. In other foreign countries, they are practicing for more than 20 to 25 years. So we are lagging behind of 20 to 25 years compared to the foreign countries construction facilities and the machineries available. Slowly, we are all picking up. So we are going to cope up with the foreign countries also. So all the things, right, properties are available in the case of the IS code IS 456. So for each and every material and also the wind pressure and how to calculate the say self load or self height of the given materials and how to calculate the minimum load to be taken for the best வாழ்க வையகம் வாழ்க வளமுடன்